What's up, guys? So today we're going to be doing a logarithm style derivative question. This one is determine the slope of the tangent line to the following function at x equals 3. So just like all questions involving finding the slope of the tangent line at a point, we're just going to take our derivative and then plug in the point that the question specifies. And so the rule that we're going to be using here is the sort of complex logarithm differentiation technique, which is if you have a function, we'll call it g of x equals log base b of h of x. So you've kind of got like a function inside of your logarithm like we do here. The derivative is going to be 1 over h of x, so the thing that we have in our argument, times the natural log or ln of the base, and then multiplied by the derivative of h of x. And the reason we've got to do that is because of the chain rule, right? If you've got a function inside another function, when we take the derivative, we always have to multiply by the derivative of that inside function at the end. And actually a nicer way of writing this is just throwing the h prime of x up on the numerator, because 1 times h prime of x is just h prime of x, so it just makes things a little bit simpler. All right, so we'll move this over to the side. So let's try to apply that to this function here. Now, the first thing that we might want to do to make this a little bit easier on ourselves is just kind of like factor that 3 out. Now, it's already sort of factored out, but I'm just going to put brackets around the rest of the function and just ignore the 3 in the meantime, because what you're always allowed to do when you have sort of like a constant multiplied over the entire function is take your derivative, ignoring that constant, and then just multiply it in afterwards. So this would turn into f of x equals 3, and then in brackets, ln x squared minus 2x. And so this is going to be the part that we're going to focus on. So with our derivative rule, this is going to turn into 3 times, and then using this formula right here, we've got the derivative of our inside function on the numerator. So the derivative of x squared minus 2x is just 2x minus 2 by the power rule, right? And then we're going to divide that by our inside function, which was x squared minus 2x, and multiply it by the natural log of the base. So this is going to be ln e. And that's because ln is just the same thing as log base e of x. I should say ln x is the same as log base e of x. Okay, now one thing to note though, ln e is really just 1. And that's because this is, if we kind of follow this rule, this is just asking for log base e of e. And you could either remember this as a log rule, where if the base and the argument are the same number, this just always equals 1. Or you could think about it more intuitively and say, okay, well, a logarithm asks, what exponent do I have to put on my base to make it equal the argument? So if those are the same thing already, you don't really need to put any new exponent. So the answer to that is just going to be 1. All right, so we can simplify this a good bit, right? We can sort of multiply that 3 into our numerator and just get 6x minus 6. And on the bottom, ln e is just going to be 1, so we can just write the x squared minus 2x in by itself. All right, cool. So the last step now is we want to find the slope of the tangent at x equals 3. So that just means we need to plug 3 into this function. So if we do that, f prime of 3 is going to be 6 times 3 is 18 minus 6 over 3 squared, so 9, minus 2 times 3, so minus 6. All right, we just subtract those, so 18 minus 6 is 12, 9 minus 6 is 3. Sorry, I should have put the 3 in the brackets here. All right, and so we finally get f prime of 3 is 12 over 3, which is just 4. And so that means the slope of the tangent line to our function at x equals 3 is 4.